Hello again, everybody. All right, this is just a quick little review for weather lesson 1-3, just to kind of make sure that we're all up to date on what we learned before spring break. So the big key concept that we left away with was when liquid water becomes warmer, it can evaporate and become water vapor in the air. All air contains water. So make sure that you have your key concepts up to date in your binder. Okay. And a word that we're going to be using throughout the whole unit is air parcel. This is the amount of air that moves as a unit. So in this picture right here, we have an air parcel above Earth with a cloud in it. Okay. In the sim, this is what our air parcels are going to look like. This rectangular prism area. Excuse me. Now, these smaller sections that we study really help us understand how the air is moving through the Earth. But, in real life, air is not divided into these separate parcels, okay? This is just something that scientists use in order to understand things better. Kind of like the latitude and longitude lines. Once again, there's not real latitude lines or longitude lines written on the Earth, but we put them there. We draw globes and maps with latitude and longitude lines because it helps us understand it better. That's the same idea with parcels as well. So once again, we use the sim in this unit to kind of help us understand a little bit what's going on. We did the condensation experiment like really fast right before spring break, so it didn't go as well as we were hoping. But what we did see that the bag in the cooler, you can kind of see a little droplets started to form. We started to get a little bit hazy. The bags that got put in the cooler, and it was a lot, there was the ice in there. The bags that stayed at room temperature, there was no change. We didn't see any of those little droplets starting to form in the baggie. Okay. We also tested this idea in the sim. We wanted to see by changing the surrounding air temperature, okay, right here, 20 degrees Celsius, and then we had the air partial temperature was 37 degrees Celsius, and we kept our water vapor about the same. And then we were able to kind of analyze what was going on in each one of these sections here, that we could see how much energy was transferred out, the amount of liquid water, the amount of rain, and then the total liquid or the rain and the cloud together. We also then did that again with a really cold air temperature down to 4 degrees Celsius, and the rest of the information was kept the same. That's a fair test. And we noticed some big differences. We saw right away that this test, when it was a lot colder outside, the surrounding air temperature was colder, there was a lot of energy transferred out of the cloud. We saw a lot of energy leaving the cloud. We therefore saw a lot more liquid water in the cloud as well, 4 kilograms. And because there was a lot more liquid water in the cloud, it then produced a whole bunch of liquid rain, a lot more liquid rain. And so this is what we're looking at. We can definitely see that when it is warmer, there's not much rain being produced. But when the surrounding air temperature was cooler, there was a lot more rain being produced. So this is an idea we're going to keep coming back to kind of understand why this is occurring. Okay. We're going to be talking once again a lot about energy transfer. This is a big idea, especially in the weather unit. Where is the energy moving? How is it moving from one place to the other? We're also going to come back to this idea of temperature, how hot or cold something is. Remember, temperature is a measurement of how hot or cold something is. And the other word that we're going to use a lot, again, is transfer, to move something from one place to another. Just like in the OAC unit, we were looking at to see how warmer air or warmer areas were being transferred to colder areas, or warmer currents transfer their energy to colder currents. You're going to see a lot of these arrows throughout the sim, and these are our energy transfer arrows, meaning that the energy is leaving the air parcel there. Okay, here's our warmer air, and then if the surrounding air is cooler, we have a lot of energy leaving. And that's kind of what we see here. In both of these tests, energy was transferred out of both of the air parcels, so that's something to keep in mind. However, there was just a lot more energy being transferred out in the test with the cooler air temperature. Okay, so we can kind of take a look at that. And we definitely just see a lot bigger cloud being formed on this one with the cooler temperature. And then why and when does this condensation happen? Well, the surrounding air is cooler, the air parcel is warmer, and what do we learn from the OAC unit is that energy transfers from warmer locations to cooler locations. And that's going to be the same in our weather unit as well. As this is happening, though, as the energy is transferring, that's what's going to be happening. The water vapor in this parcel is going to cool, and then it's going to condense together. Those water droplets are going to get closer together, forming larger water droplets that can then eventually form rain. So when the water vapor in an air parcel cools, it can condense into liquid water, which can form a cloud, and then eventually falls as rain. So please make sure that you have your key concept all caught up. Please, of course, always pause the video if you need. So in both of those activities that we did for this unit, we saw energy transfer happens. Okay, that's definitely letting us know that condensation is occurring. In real life, we can't see the energy being transferred, and that's one of the ways that the simulation is really helpful because it can help us see how it's being transferred, and we can also measure it in the sim. Okay. All right, please go back in Google Classroom and see what, make sure that you've completed all the assignments for today, and I hope you have a wonderful evening. Go outside, look at some clouds.